All right, so here we have a AA battery that I just drew, and we're going to talk about what makes the electricity happen or occur from just a battery. So this is a chemical reaction, right? AA battery, and the type of reaction we have in here is chemical. And the way that the battery works is that if I were to just draw a line like this to conceivably break the battery into two separate components internally, right? We've got two different chemicals. So you've heard of like copper nickel batteries. That used to be the tech. Now we've got lithium ion, right? And the point is that there's two different chemicals inside. And one chemical, like if we were to use copper for this example, copper is a 2 plus or something like that, meaning that it's giving off electrons, right? And then we've got something like nickel, which is a 2 minus, meaning that it's always looking to accept electrons, right? And since one side's giving them off and one side's accepting them, if we give them a chance, meaning a pathway where they can push or pull each other, right? Now we've got electricity moving out of the battery. And obviously this would be a short circuit. We don't want to do this. Boo! Because this would give, if we short circuited, we'd have a place for the electricity to move from one side of the battery directly into the other side without utilizing or resisting any of the flow of the electricity or using it up. And that would overload the battery, and that would be bad. Back to this, we got these two different chemicals, and what else can we say about this battery? Chemical equation, two different chemicals. That's right, we could say the voltage. How many volts? If you look on the side, you'll see it's 1.5 or 1.5, as the Canadians say in that warm-up video. And we already short-circuited one of these on purpose to see the outcome, the experiment with the effect. And we know that the most dangerous thing that would happen is you wouldn't even be able to feel a shock, but you would generate heat and you would feel that warmth, and that could be bad, and that you would just pop the battery out of your battery pack if that occurs, and then probably get rid of that battery because it will have been drained. All right, now we can. How long does it take to drain them? Well, it would be more than a couple seconds of short circuiting. If it was hooked up for a few minutes, that could be enough time to do it. Now let's look at some popular misconceptions when it comes to batteries and how dangerous they are based on their size and things like that. We'll draw a second battery in here. I think everybody knows what this one is from your smoke detectors. All right. What kind of battery goes inside the smoke detector? Something like this. It's got the two little pieces here, a male side and a female side. All right, that's right. This is a 9-volt battery. 9-volt battery. And what else do we know about a 9-volt battery? Well, if we were to short circuit the 9-volt, maybe you did this with your tongue as a kid. Mom and dad tell you to go check and see if the battery's still good in the smoke detector. You pop it out, touch it to your tongue. You feel a little bit of a uncomfortable feeling for sure, that vibration, a little bit of a shock. Again, you're not being electrocuted. If you're being electrocuted, that means you're dead. And a little bit of a shock, and that tells you that the battery's live, right? And you could also take two 9-volts and connect them to each other end to end. That would be bad. That would be a short circuit between two batteries. That would be really bad because that would generate a lot more heat. And you definitely could use 9 volts with these with these LED lights that we're working with. But in the configuration that we're working with, we're going to be doing our parallel circuits with AA's. If you were to move up to 9 volts, you could still figure it out, but you would probably be running a couple of your LEDs in series. We're not concerned with that for the design challenge. All we're worried about is a parallel circuit with AA batteries. We want to make sure everybody is self-confident when it comes to the dangers, where you're safe, what's dangerous. So we got this 9 volt here, and what else can we say about the 9 volt? A lot of times there's a battery snap that pops on the back of the 9 volt. I think you may have some of those in your kit too, but you don't need them right now for anything. All right, now we've got another uh, type of battery that I'm going to draw. The size of this is much different. All right, this battery is as big as a shoebox or bigger. Right, and you pick these up at the auto store. Sometimes this type of battery will die, and you'll have to jump start your car. It's car batteries, right? Now the positive and the negative part on a car battery, or the terminals, if you will, you could also call them the anode and the cathode. But these terminals on a car battery are super soft, and they're usually made of lead, and they're soft for a reason, so that when the terminals are hooked up, terminal cables are hooked up and tightened. When the car bumps around or shakes or is moving or hits something, the terminals won't pop off, right? So that this battery is always going. Now, what happens if you were to short circuit one of these batteries? First, I want you to guess how many volts you think are here if you don't know already. Right? Remember, this is big, fits in a car. How many volts do you think it is? We've got this. This is the 1.5 volt AA battery. Here's a 9 volt battery, similar in size to the AA, but these are nowhere near as big as the car battery, which I said is bigger than a shoebox, probably weighs at least 25 pounds, if not heavier. So you keep that guess in the back of your mind. Some people guess, well, the guesses are all over the place. If you're just going based on size alone, on this model, you might think, wow, this must have hundreds of volts in it, if not dozens, right? Well, I found out one time when I short-circuited a car battery by mistake. I was changing a car battery out, and I was using a wrench to loosen the terminal nuts, and the wrench wasn't coated with any rubber. It was just an open crescent wrench. I was holding on to the wrench, and as I went and I twisted around from one side to the other, the two ends of the wrench crossed and bridged across the two terminals, right? And as soon as they did that, what did I create there? That's right, a short circuit. And I saw a big flash, right? And uh, I got knocked back off the car, actually, and I woke up on the ground a second later. I came to or whatever, and I couldn't see out of both my eyes. My one arm was completely numb, and all my vision, all that, everything came back. But I thought that I had gotten electrocuted, right? And turns out I wasn't electrocuted. I was just shocked really bad. Um, and the funny thing about this is um, that the car battery only has 12 volts. Yep, that's right. Only 12 volts in the car battery. How the heck does that happen? Where when you short circuit here, it gets a little warm. You short circuit the 9 volt, you can definitely feel it across your uh, tongue. And with 12 volt, it caused a temporary injury that I thought was going to be permanent when it first happened. Oh my gosh, I was probably 17 years old at the time. Um, well, there's a few reasons why this is so much more drastic, 12 volt, and that's because voltage is not the whole equation when it comes to what makes electricity safe or dangerous. It's just one piece of it. If I'm going to write the equation up here for us, we could talk about how voltage is equal to current times resistance. Voltage is equal to current, which is often measured in amps, not often, but is measured in amperes. We're going to represent current with the letter I, and times ohms of resistance. So we can write that out. And the final equation that you typically see people write it out, voltage equals current times resistance. V equals IR. V equals I times R. So I can tell you right now that in one of these AA batteries, there's not that much amperage running through here. Not that much. Not that much current. Current probably anywhere from 0.01 to 0.1. Right now, it's the current that really can mess you up. The current inside of a 9-volt battery, probably somewhere around 0.1 amps, 0.1 of an amp. But the current going through a 12-volt battery inside of a car can be somewhere between approximately 300 amps. Wow, right? That's the major difference here. 300 amps. Now, a regular battery here is DC current. It's going to be DC, which means that electricity, as it's moving, it's moving, you could say, directly or in a straight line. Same thing with a 9-volt battery, moving directly in a straight line. But if we were talking about your house and we were talking about AC inside of your home, AC current is alternating current. Now, all this stuff is not important for you to be able to reproduce on a test. It's just for your to help you build up your background knowledge or put some of the pieces together that you may have learned back in 5th grade, right? And both of these batteries, DC current, these go dead. They don't recharge. A car battery, even though it's a chemical reaction too, the whole car system, the electronic system, is only a 12-volt system, and but these batteries are called deep cycle batteries. Deep cycle, meaning that your car battery is constantly discharging and recharging, right? Because it's not just hooked up directly to run, the lights and the electronics inside your car, but it's hooked up to the alternator of the car, and the alternator is what spins and generates electricity as the car moves, and that electricity goes back into filling up the battery, right? But it's these 300 of amps that make a car battery so dangerous if you were to short circuit it. So we know the amperage is the most dangerous thing, and let's draw one more for funsies just to make a comparison here. All right, and this one we're going to draw. If you were to order one of these online for your safety, and you live in New Jersey, you wouldn't be able to get it shipped to your house because that's not allowed. You have to live in another state. I found out recently trying to pick one of these up for my wife as a little stocking stuffer. That's right, it's a taser, a little personal taser. You can get them for like $10. And you've seen what tasers do, right? Push this up against somebody, squeeze the button. People are rendered helpless as long as they're being hit by the taser. They take the taser off, they can move again. But they're not considered deadly weapons. It's supposed to be, it's considered a non-lethal weapon. So it's not electrocuting you, it's just shocking you. How many volts do you think are in a taser? Now, you may have seen one or think, well, how big could a battery be that fits in there, right? A taser might only take a 9-volt battery or something like that. But the amount of voltage in that taser is like 20,000 to, I don't know. I think I've seen them go as high as 100,000 volts. So 20K to 100,000 volts, right? And you think, man, that's a lot more volts than 12 or 9, right? But if that's the case, and this is not enough to electrocute you, you're just getting shocked real bad, what's that tell us about the amperage in this equation? V equals IR. Super high voltage, and that's right. If you guessed super low amperage, you'd be correct. Right, so super duper low amperage. Now, you don't have to be concerned with calculating up Ohm's, is it Ohm's law? Yeah, you don't have to worry about Ohm's law and doing any calculations with it, but understand that when it comes to, we know where the voltage is coming from, in these cases, chemical reactions. We know that uh, current, the current is, we consider that to be maybe how fast that voltage is moving through the circuit. When there's a lot of current, it's moving, how fast is it pushing the voltage through? Super high current pushing through voltage is very dangerous. And where does the resistance come from? We said resistance is anything that's using up or resisting the flow of the electricity inside the circuit. So the battery itself, just by the fact that it's a physical thing, is going to have offer some resistance. The wires themselves, are going to have resistance. In fact, copper offers low resistance to the flow of the electricity, but copper is not the best conductor. Something with the lowest amount of resistance you could get might be platinum or gold. That'd be super low resistance and the electricity can move through easier. Or if you want to think about resistance, the main thing most people consider with resistance is what is it that's using up the electricity in your circuit for the most part, right? For us, there's going to be LEDs. It might be a motor in a different situation or whatever else is in there resisting the flow of the electricity. Since we're not doing any soldering, which is really awesome because speaking of resistors, you can get little circuit components called resistors. I just don't have any sitting here in front of me. And resistors are these little extra components that when you are soldering, if you want to add just the right amount of resistance so that your LEDs don't get too much electricity, you could solder in individual resistors that have different values on them. But for what we're doing here, the AA battery pack will perfectly work with our LEDs without having to add any resistors or do anything else to the circuit. But just note this: when we're doing this, you can't use red or yellow LEDs. Red and yellow LEDs will not work out because, or orange, because for some reasons, well, I know that red, yellow, and orange require less voltage. And so anytime I've done this with lights, white's fine, blue, green, purple, pink, all those colors of LEDs or incandescent bulbs will be fine. But if you switch over to an orange, red, or yellow light, all of a sudden the AA battery pack becomes too much and will make the lights get really bright and they'll burn out real quick. Right? Otherwise, you can bet that that your LEDs are going to last a lot longer than your batteries when we make these circuits. And the better the quality of the battery that you buy, the much longer it will last. Right? So you can get batteries that go anywhere from $1 each up to $10 each, depending on the quality of the battery, and they'll definitely last much longer. All right, so we talked about Ohm's law, and we addressed the misconception that it's the voltage that hurts people if they get shocked or electrocuted. It's really, there's a bigger equation here, and in those cases, you want to be paying attention to the amount of amperage that's in the system. This is why when I short-circuited a car battery, I got shocked real bad because of the high amount of amps, which is like how fast the 12 volts are able to push through that system. All right. Great. Well, let's jump off this part of the video into the next thing.